Hello. This videotape, the first in our elementary algebra sequence, is entitled Introduction to Algebra, Algebraic Notation and Order of Operations. Algebra is a branch of mathematics that deals with manipulating symbols that represent numbers. In certain ways, studying algebra is a lot like learning a new language. First, you have to learn the alphabet, then the vocabulary, then the rules and the grammar, before you can really do anything with the language. And the same is true for algebra. In algebra, our alphabet consists of 1, numbers, 2, letters which represent numbers, which we will call literal numbers or variables, 3, symbols for the arithmetic operations and equality. Most of these you're familiar with. For example, for addition, we use the plus sign. And this is the equal signs. 3 plus 4 equals 7. For subtraction, 10 minus 7 equals 3. For division, 12 divided by 3, or 12 divided by 3 written this way, equals 4. And for multiplication, well, in arithmetic, you usually wrote multiplication with this time symbol. 3 times 4 equals 12. In algebra, we tend to prefer to use a little dot here to indicate multiplication, because the time symbol can get confused with the letter x, which very often represents a variable in algebra. We can also use parentheses around the 3 and the 4 to indicate multiplication. The dot can also be placed between the parentheses if you want to emphasize the multiplication, or you can write it this way, with the 4 in parentheses and the 3 not. All of these mean the same thing. If you are using letters to represent numbers, if you're using variables, A dot B means A times B. You can also write A, B next to each other without any punctuation in between, and this will also mean multiplication. Of course, you can't do this with numbers. 3 times 4 is equal to 12. It is not equal to 3, 4, which is the number 34. But if you're using variables and you write the two letters next to each other without any punctuation, it means the dot is there. Okay, the dot is implied. It means multiplication. But it only works for letters, not for numbers. We also have grouping symbols in algebra. We have parentheses, brackets, and braces. If I were to write 4 times 2 plus 3 in parentheses, this means 4 times the sum of 2 plus 3. That is 4 times 5, or 20. In the beginning of our study of algebra, we will be dealing with the natural numbers. These are the positive whole numbers. The natural numbers, the positive whole numbers, or the counting numbers, 1, 2, 3, 4, and so on. If we want to indicate the set of natural numbers, we can put braces around the elements of the set. This is a set of natural numbers. 1, 2, 3, 4, dot, dot, dot means it's going to continue in the same pattern. These are the positive whole numbers, the natural numbers. Now, the natural numbers can be broken up into two subsets, the set of even numbers and the set of odd numbers. The even numbers are those numbers which are exactly divisible by 2. 2, 4, 6, 8, so on. The odd numbers, the odd natural numbers, are those natural numbers which are not even. 1, 3, 5, 7, and so on. We can also divide those natural numbers over 1 into two subsets, prime numbers and composite numbers. A prime number is a natural number over 1 that is only evenly divisible or exactly divisible by itself and 1. It has the only whole number factors that it has is itself and 1. For example, 5 is a prime number, or a prime. Right? 5 is equal to 5 times 1. These are the only natural number factors of 5. 7 is also a prime. 6, however, is not a prime, since 6 can be written as 6 times 1, but also 2 times 3. Since it has whole number factors, positive whole number factors, other than itself and 1, 6 is not a prime. 6 is a composite number. We are now ready to set up rules for evaluating algebraic expressions. Let's look at this problem. 4 plus 2 times 3. Okay, now one person looking at this might say, well, 4 plus 2, that's 6, times 3 gives me 18. Somebody else looking at this problem might say, well, 2 times 3, that's 6, and 4 plus 6 gives me 10. Okay. This was from thinking of it as 6 times 3. This from thinking of it as 4 plus 6. We don't want two different people working out the same problem and getting different answers. We have to clear up ambiguities like this. So what we're going to do is specify an order in which arithmetic operations are going to be performed. And when we've done this, it will be clear that the answer to this problem will be 10. Let me list the order of operations for you over here. When you have to evaluate an algebraic expression, the first thing we're going to do is take care of the part that's contained within grouping symbols. Then we will proceed from left to right through the expression, handling first the multiplications and divisions. Then we will go through the expression from left to right again, this time handling the additions and subtractions. Remember, we are proceeding here from left to right through the expression. Once more, we first handle what's contained in the grouping symbols, then moving from left to right, we go through and do all the multiplications and divisions, and then finally go through and handle the additions and subtractions. Okay, now let's go back and look at that problem again. We can see now that there can be only one way to do this problem. There are no grouping symbols, so we go through this expression here, and the first time we ignore additions and subtractions. We're only looking out for multiplications and divisions. And the first thing we see is this multiplication. We perform the multiplication, giving us 4 plus 6, and then we go through again doing additions and subtractions. 4 plus 6, of course, gives you the 10. This is the correct answer. The only way a problem with these numbers, say, could give you the answer 18 would be if the 4 plus 2 were contained in parentheses. If I had 4 plus 2 times 3. Okay, now according to order of operations, we first handle the things that are contained within the grouping symbols. And we see that we have 4 plus 2. This addition is to be performed out of order. Okay, because of the grouping symbols, we don't handle multiplications first. We handle what's in the grouping symbols. And this way, we can get the addition performed before the multiplication. This would give us 6 times 3, which, of course, gives you 18. But unless those parentheses are in there, this is going to be handled in this fashion, giving you the answer of 10. Okay, I'm now going to put down 4 problems for you, which all look alike, but they're done differently. Okay, we have to be very careful where the parentheses are, and let's try these problems. 10 plus 2 times 8 minus 3 in parentheses. This dot here is really optional. Okay, without it, it would still mean 2 times 8 minus 3 in parentheses. 10 plus 2 times 8 minus 3. 10 plus 2 in parentheses times 8 minus 3. 10 plus 2 in parentheses times 8 minus 3 in parentheses. These 4 problems all involve the same numbers, 10, 2, 8, and 3. And the same operations, multiplication, addition, and subtraction. And yet they're all going to give rise to different answers. Okay, let's work these out using order of operations. Okay, the first problem. We go through it from left to right, first time only being on the lookout for things that are contained within grouping symbols. And we see we have 10 plus 2 times. Now, 8 minus 3, this subtraction is performed before everything else because it's contained in the grouping symbol, giving us 5. 8 minus 3 in parentheses is replaced by the 5. Okay, now we have no more grouping symbols. These parentheses here are just to indicate multiplication. We can leave them out, in fact. Okay, no more grouping symbols. We go now from left to right, this time looking for multiplications and divisions. Okay, we ignore the addition. We proceed right to the multiplication, giving us 10 plus 10 for a final answer of 20. We go back and we do the addition. Now let's look at the second problem. There are no grouping symbols. This means we will go through this expression from left to right, now being on the lookout for multiplications and divisions. Okay, so we ignore this addition, this stage. The first thing we handle is the multiplication, 2 times 8 giving us 16 minus 3. Now we go through from left to right, handling the additions and subtractions. 10 plus 16 gives us 26 minus 3 for an answer of 23. Okay, in the third problem, we see that we do have a grouping symbol. Therefore, we will perform this addition first, out of the order of operations. The addition will come first because it's contained within the grouping symbol. This will give us 12 minus 3. We now go through again, this time handling the multiplication first. Okay, you do not make this 8 minus 3, you do not make this 5, okay? You use order of operations. First comes multiplications. This gives you 96 minus 3 for a final answer of 93. And in the last problem, we have grouping symbols here and here. We will perform this addition, and then this subtraction, and then finally the multiplication. 10 plus 2 will give us 12. 8 minus 3 will give us 5. And then finally, 12 times 5 will give us an answer of 60. Let's try some more problems. 15 minus 5 times 6 minus 4 in parentheses. If you want to try this problem on your own, you can shut the videotape machine off and turn it back on as soon as you've finished. Okay, we go through this expression looking for grouping symbols first. We see it over here. We get 15 minus 5 times 2. We perform this subtraction first because it's contained within grouping symbols. When there are no grouping symbols, then we go from left to right, handling multiplications and divisions first, and then finally, from left to right, we will do the additions and subtractions. Okay, you must resist the temptation to make this a 10. Okay, the subtraction will have to wait until after the multiplication is performed. giving you 15 here minus 10 for a final answer of 5. Let's try one more. 4 times bracket 5 plus 3 times, in parentheses, 4 plus 1. We have 2 levels of grouping symbols here. Okay? With grouping symbols, we work from the inside out. First, we'll handle what's contained within the parentheses, and then what's contained within the brackets. And we could also have braces in here, too. Okay, from the inside out on the grouping symbol. So we will go through. Now, 4 plus 1 gives us 5. This is 3 times 5. So it's 4, bracket, 5 plus 3 times 5. Now we handle what's contained within the bracket. Okay. Now, inside the bracket, once again, order of operations holds true. We will go from left to right within the bracket, handling multiplications and divisions first, and then additions and subtractions. So this will give us 5 plus 15. We don't make this 8 times 5. We do the multiplication first. We get 15 plus 5 gives us 20 now in the bracket. 4 times 20. Okay, when you have 2. We will now evaluate some algebraic expressions that are written in terms of variables. And we will substitute in values for the variables. Okay, I want you to evaluate for x equals 2, y equals 3, and z equals 4. The following expressions. Z times x plus y in parentheses, and then also zx plus y. Okay, now what you have to do in a problem like this is first go through the expression, substituting in the proper values for x, y, and z. This problem will then begin to look like the problems that we've been handling on order of operations. You'll follow order of operations and get the answer. Okay, the important thing is to make sure you do your substitution very carefully. This is z times x plus y in parentheses, so it's going to be 4 times 2 plus 3 in parentheses. I've substituted for z, x, and y. Now, using order of operations, we perform this addition first because it's contained within the grouping symbols. We get 4 times 5 for an answer of 20. Now down here, zx plus y. Zx means, of course, z times x. When you write it down in numbers, you can't, however, just write 4, 2. You have to write 4 times 2. Plus y, so plus 3. Okay, zx is really z dot x. But when you have letters representing numbers, okay, when you have variables, you don't have to actually put the dot in for the multiplication. But with numbers, you certainly do. Okay, according to order of operations, we go through from left to right. First, we perform multiplication and divisions, and then we go through again additions and subtractions. So we get 8 plus 3 for a final answer of 11. We now know enough to begin formulating algebraic expressions and equations. In general, a sentence in English will translate into an equation, and a phrase in English will translate into just an algebraic expression. What I want you to do is to translate each of the following into an algebraic expression or equation involving the variable x. Our first problem, 10 more than a number. We want to express this phrase in English algebraically. 10 more than a number. X will represent this general number. 10 more than a number will be written x plus 10, or 10 plus x, it doesn't matter. Addition is commutative, so x plus 10 and 10 plus x mean the same thing. The order in which you perform additions does not matter. 10 more than a number x, x plus 10. A number increased by 10. A number x increased by 10. Once again, we get the answer x plus 10. A number increased by 10. Three, a number decreased by 10. A number decreased by 10. A number x decreased by 10. X minus 10. A number decreased by 10. Ten decreased by a number. Now, see here it was a number x decreased by 10. X take away 10. Here you're starting with 10. It's going to be decreased by a number x. That is 10 minus x. 10 decreased by x. 10 decreased by a number. Why don't you try these two? 6 less than x. 6 less than x, or 6 less than a number, and x less than 6. Six less than x, and x less than 6. Okay, for 6 less than x, we get x minus 6. For example, 6 less than 10 would be 10 minus 6, or 4. X less than 6, 6 minus x. For example, 2 less than 6 would be 6 minus 2, or 4. Okay, let's try some more. 5 more than 3 times a number. 5 more than 3 times a number. Okay, 5 more than 3 times a number x. Well, 3 times a number x can be written 3x, or 3 dot x, but you don't have to put the dot in. It's clear that we mean multiplication. 5 more than that, you'd have to add on 5. This is 5 more than 3 times the number x. Okay, let's try translating this. 15 is 5 more than a number. 15 is 5 more than a number. Notice that for the first time we are talking about a complete sentence to be translated. This is going to translate into an equation. The is going to translate into the equal sign. Notice that in the problem before it was just a phrase, 5 more than 3 times a number. This is different. This is a sentence. 15 is 5 more than a number. 15 is, or equals, 5 more than a number. Okay, that could be written x plus 5 or 5 plus x. 15 is 5 more than some number x. And let's try one more of these. Twice a number is 6 less than 4 times the number. Twice a number is... Once again, this is a sentence. We'll translate into an equation. The is will go into the equal sign. X will represent the number. Twice a number, or 2 times a number, 2x is or equals 6 less than 4 times a number. 4 times a number and 6 less than that. 2x is equal to 4x minus 6. Twice a number is 6 less than 4 times the number. This brings us to the end of our first videotape. If you have any questions about this videotape, you can consult with a tutor in the math lab or view the videotape again.